Okay, this is Mr. Sitta. I'm going to go over the Chapter 17 review on buffers, and we'll start with number one. What does a buffer do? It keeps a pH relatively constant. What substance are present in a buffer? Okay, uh, and what you have is a weak base or an acid, and its conjugate, which we just call a salt. Okay, so an example of a buffer would be a weak acid like HF, and it would be in presence of its conjugate, fluor, uh, fluoride. So you have a weak acid and its conjugate base. If I had a weak base, example of a buffer would be um, ammonia. Its conjugate acid you get by adding an H, so you get NH4. Now when you see these conjugates, they're present as salts. So I need a counterion, which is, I'll pick some type of soluble ion, which is just a spectator ion, so sodium fluoride. And if I was in the case of ammonium, I would pick ammonium and then add a soluble salt, ammonium chloride. And that's what they mean by their salts. But once you look at the action of it, the spectator ions, you would just want to take away. All right. The addition of hydrofluoric acid and what would produce a buffer, you would be looking for fluoride. And you have to have a counterion, so it's NaF. But as soon as you look at it, you're just disregarding the sodium because it's a spectator ion. The addition of ammonia and water produce a buffer solution. I'm looking for ammonium, and just look at it up here. I need a counterion, so it'd be ammonium chloride. Again, I would discount the counterion as a spectator. The solution containing which of the following pairs will be a buffer solution? Not a strong acid, not a strong acid, not a strong acid. Okay, there's the salt of fluoride, so it would be D. A weak acid and its conjugate base, fluoride. Which one's not a buffer? Okay, this is a weak acid. That's its conjugate base. Check, that's a buffer. Acetic acid and sodium acetate, that's a buffer. Ammonium hydroxide, that's a strong base, not a buffer. Ammonium hydroxide, no, I don't want the hydroxide there. So just because the hydroxide's there, I'm discounting those. Ammonia and ammonium, and it's with bromide, E would be my solution. Okay. Of the following solutions, which one has the greatest buffering capacity? Buffering capacity, I didn't talk a lot about that in notes, but when you have a weak acid and its conjugate, you want them relatively to be equal to each other. That will give you the most capacity. So I'm looking at 0.0821 and 0.919. These are both the highest numbers here. This is just a lower number. These are lower numbers. That's lower than that. So B, they're both relatively high. That would give you the most buffering capacity. A solution is prepared by dissolving 0.23 moles of hydrofluoric acid and 0.27 moles of sodium fluoride in water, causing it to yield 1 liter. The addition of 0.05 HCl causes the pH to drop slightly. Okay, so what I have a solution which has HF in it, and it has fluoride in it. Okay. When I add the HF, it reacts with which of these? Well, this is your acid, your weak acid. There's your conjugate base. So the reaction would be, if I add a strong acid, okay, it would react with the weak base, the fluoride, to produce more HF. That would increase your HF, like that, and it would decrease the F. So the answer is it reacts with the fluoride. Okay. That's the whole concept of a buffer, is that you have a acid and a base both present in it. Either one would react with a strong acid, or if I added hydroxide to this mixture, the hydroxide would react with the HF to increase the amount of fluoride. Which shows what happens when nitric acid is added to ammonia buffer. You have NH4 and NH3. That's the weak base, that's the conjugate acid. So if I'm going to add nitric acid, HNO3, I don't really care about the nitrate, it's a spectator ion. I'm adding acid, H+. It's going to react with the base, NH3, to increase your ammonium. So H++ NH3, A, produces NH4. What happens when I add potassium hydroxide? I'm only looking at the hydroxide here. Potassium's a spectator ion. Is added to the same ammonia buffer. The base is going to react with the, that's a weak base. The base is going to react with the acid, so hydroxide would react with the ammonium, which produces ammonia. H gets donated back to the OH plus water. That's B. And the way to do a problem like this is to just do it open-ended and compare your multiple choice to that answer. What takes place when I add a strong acid? So I'm adding H plus to a solution of acetic acid and acetate. So a weak acid and its conjugate base. It's going to react with the conjugate base, CH3COO. And it's going to produce CH3COOH, acetic acid. I like to just look at that as acetate, make an HAC. And that would give me C. Okay. Let's see. The Henderson-Hasselbalch pH equals pKa plus the log of your base over your acid. You should know the Henderson-Hasselbalch solution. Now, consider a solution that is 0.1 fluoride and 0.126 hydrofluoride. I'd always start with an equation. So I have water reacting with HF. The H will donate the hydrogen, and that gives you fluoride plus water, H3O. Alright, I have 0.126 molar HF, I have 0.100 molar fluoride. Label this weak acid, conjugate base. That means I have a buffer. I know the Ka, and I can use the Henderson-Hasselbalch equation. pH equals pKa plus log, and my base will be F fluoride over HF. So negative log of 3.5 times 10 to the negative fourth plus log of 0.100 over 0.126. So we got negative log of 3.5 to the negative 4. This number is 3.46 plus the log of 0.1 divided by 0.126. That's 0.10. And it's negative. So your answer should be 3.36 equals my pH. see. Okay. I'm only seeing 2 sig figs here. So they're coming out with 3, but because your KA is just 3.5, you're not going to get that's 3 sig figs and you only have 2. Okay. I'm going to do the second clip one, second one.